let's
Okay,
see.
guys. I hope everyone is okay. Let's start. We have a lot of material to cover. So before we run the webinar, let me spend a couple of words about Bob. You know, Bob Johnson, our guest speaker today, has many years of experience. I say more than 30, but I don't want to make you look any older than you are. In the EX world, he's also a CompEX instructor and instructor of the ICEX COPC scheme. And of course, he's an inspector, member of the US ULSTP committee. So he has a lot of experience, and we run this webinar. Before we do so, though, I need to spend a few words about the GMI, who's presenting the webinar. I am Paolo. I'm the VP of Sales of GMI. So let's go to the next slide, Bob. So GMI is a company designing, engineering, and manufacturing a complete range of intrinsically safe and certified devices, which are used in automation packages such as DCS, ESD, fire and gas, and so on, in all the industrial sector. Primarily oil and gas, petrochemical, pharmaceutical, but also food and beverage, and so on. We have over 40 years of experience, and we are very proud to manufacture our product in our facility near Milan, Italy. On the other end, we are a global player with presence in all the continent. Let's see next slide. And here we see we have 10 offices around the world. We have many distributors, and we run many webinars, seminars, but also cybersecurity, functional safety, and EX training program. Next, Bob. As I said, we manufacture our product here in Italy in a state-of-the-art facility. Because we make safety product, we try to manufacture them as best as possible. So we have, for example, full traceability, 100% testing. We offer 5 years warranty. Of course, because they are safety products, so they maintain the plant safe and operational. I was discussing this with our new general manager the other day. Our products are a very, very narrow portion of the overall cost of the plant, but they make sure that the plant run and remain safe. So they are important products. So we take special care in manufacturing them. Next. Designing and manufacturing them, and they are certified. Of course, we have full certification, EX certification around the world. We are functional safety manager TUV certified up to C3, so SC3, ISO 9001, 45,000. There's a missing one here. There's a new one, 18,000. We are ROSA Rich compliance, and so on. So let's see next slide, Bob.
You bet.
These are the products. IS barrier up to SIL 3 certification, safety relay, which are also SIL 3 certified with and without line monitoring. We have isolators, which are also SIL certified, power supplies, ATEX, UL, and SIL certified. We have a line of multiplexer, temperature multiplexer, digital multiplexer, art multiplexers. And we run a line of SPDs and some loop indicators. And as I mentioned earlier, we have a division that runs functional safety and EX, and today also cybersecurity courses and services. Some of our customers, most of the MAC, and of course EPC. We're very proud to supply our product to many OEMs, from ABB to Weatherford. I'm trying to look top and bottom, but we have many in the US and around the globe. And of course, we are an event AVL of many oil and gas companies around the world. I believe this is it. Go next. Yes, it's about you. I might take myself off a little bit because I don't see myself. I need to find a way to, here it is, to look a little better. So it's all up to you, guys. Before I hand it over to Bob, keep in mind there's a way for you to intervene, which is by question and answer box. You can see there. We also have taken your question and answer for the registration, your question for the registration, and we will reply to those at the end of the webinar. So just hang along. Okay, Bob, so yours.
All right, thank you, Paolo, and thank you very much for everybody to join us today. I'm, again, as Paulo said, I'm Bob Johnson. I'm based out of Houston. So for me, it's mid-morning. So I know many of you are around the world in different time zones. So I appreciate, especially, I know for those of you in Europe that are nearing the end of your day, that you've decided to spend a good 45, 50 minutes with us. So I'll try to make it brief, but I'll try to make it obviously entertaining. And again, as Paulo said, we'll try to answer some of these questions that you might have from an EX inspection standpoint. And and let me preface this by saying, I know many of you are from the folks that pre-registered are not necessarily in the inspection side of things, but it is critically important for all of the various individuals within the EX chain, if you will, everywhere from the manufacturers to the end users, to understand what inspectors are actually looking for, because we find that many faults can take place at the very, very early stage, all the way from the design stage, all the way to the implementation once it's been installed and once it's operational due to environmental conditions or what have you. But of course, electrical installations in hazardous areas, they possess these features that render them suitable for such atmospheres, right? And if we don't maintain it, we don't inspect it, we don't do the right things, then we're really, throwing good money after bad. So it's critical that we're all taking an active role, if you will, from an inspection standpoint, even though that may be not necessarily my job function all the time. But if we're all taking part of this at all different supply chain avenues, then we can help minimize these types of mistakes, right? So the main standard that really, for those of you who are interested in inspections, is the 60079-17 standard. This is kind of the Bible, if you will. And so everything that we're really going to be talking about today is pretty much out of those standards. Now, the good thing is the base standard is the IEC version, but every country, or most countries, have adopted the -17 standard as a country-specific standard. And there's very little deviations between the IEC standard and the international standards, or the European standard, the US standard, Australia. And again, other countries have variations of the theme, but the base document is that 60079-17. And you will see this referenced from a lot of clients, customers. You'll see inspection check sheets, and they'll basically have this document referenced. And we'll show you kind of some examples of some of these check sheets and what we use when we're doing inspections. However, it is important to understand a lot of major oil and gas companies will actually go above and beyond what's required in the -17 standard. Because the -17 standard, again, it is an international standard. It must be, it's basically the bare minimum, right? So many companies will take the requirements out of the -17 standard, and then they'll go above and beyond that. They may require inspections to country-specific wiring regulations, or they may say, hey, that's not necessarily good enough. We want to go above and beyond. So it's critically important as an inspector that we understand very early on, when I'm coming in to do an inspection, am I doing it just to the 17 standard? Or am I also making sure that I'm compliant to a different standard that may have requirements that are above and beyond? So it is important to understand that when we're doing inspections. Don't just use the 17 standard as the end-all be-all. Make sure that we understand all of the other project or client-specific requirements that may be involved in inspections. So what do we need to know before we're doing an EX inspection, right? And these are kind of our check sheets that I always ask questions. And we should have this available to us before we actually get into the actual inspection. Again, country regulation and client specifications, that's pretty much a given. What type of grade of inspection are we going to be doing? There are 3 different grades as defined in the -17 standard. There's either a visual, close, or detailed, which we'll talk about a little bit later. We also need to have bills of material, drawings, certificates, and certificates are extremely important to have access to when we're doing our inspections, and I'll share with you a little bit later on why that's important. An EX register or dossier, and then of course we need data sheets on the equipment. Obviously, we need to know the area classification. If we're building a skid package, what zone, category, EPL, where's it going? Is there any previous inspection schedules or records? What are our gas groups? What are our ambient temperature range? What's our T code requirements? What are the environmental issues, right? Is there some minimum IP ingress protection ratings that we need to comply with? Is there any specific material requirements that we need to comply with, such as maybe we require a 316 stainless steel material as opposed to a cast iron or something like that? And again, the important thing is this X condition when we start looking at certificates. X conditions are critically important to understand when we're doing inspections, and I'll talk about this a little bit later. And again, if you don't have this information, we're a little bit blind. We don't know where we're going, so we need to have this information to understand what we're actually wanting to do. And this is the information that you want to be able to, if you're not necessarily doing the inspections, but you want to have this information available if you're contracting out or even internally having people do inspections on your equipment, right? To save time and energy, if you have this check sheet, this is kind of a handy little guide to be able to utilize to say, hey, this is what we're going to have you do. And it's critical to do this visual, closer, detailed inspection to determine how the inspection is supposed to be carried out. So, as I mentioned, the -17 standard is our standard. We have grades and we have scheduling of inspections. So the grades of inspections, there's what is called a visual inspection, there's called a close inspection, and then a detailed inspection. So visual inspection, this is where we just walk out and we start looking at the product. We're looking for any unauthorized external modifications, maybe a missing bolt, maybe a label is missing, maybe we see damage to cable or something like that. This is typically based upon something that's already been installed. We're going out there maybe a year later and we want to check it out. You know, we've already done our initial detailed inspection at the factory or when it was first installed, but visual and close inspections are typically those inspections that are ongoing as part of our normal maintenance procedure, right? Now, the difference between a visual inspection and a close inspection is a close inspection is where we start using tools. So if we need to get up and see a piece of equipment that's high up on a ceiling, maybe a light fitting or something like that, well, now we need a step ladder. We might need a flashlight. So now we're looking very closely at things like labels, putting our hands on the equipment. We're checking the tightness of cable glands. The important thing to note, visual and close inspections can be done without de-energizing the equipment. So we can do these types of inspections while the equipment is energized and operational, right? So it is something that is typically should be done, again, by the end user. They're doing this on a regular routine basis. One thing to note, if we do find a loose gland during a close inspection, we don't want to loosen it up completely, because if we loosen up that gland, we've now lost potentially the EX certification of that product. So we don't want to open up anything. We just want to touch, feel, grab, check out labels, do all that kind of good stuff. When we get into a detailed inspection, this is where we're doing our lockout tagout procedure. We might have to have a gas-free permit. Or again, if we're doing this at a factory type environment where somebody is building something, may not be energized, so therefore we can go and start doing this full detailed inspection. Now we're starting to look at the things that might be issues internally to the pieces of EX equipment. We still look for things like bolts missing, labels missing, those types of things, but now we're going to go inside the equipment and start checking out things like, is the gasket properly seated? Are the threads, not damaged on an EXD flame-proof enclosure? Is it wired, the grounding wired correctly? Is there separation between intrinsically safe and non-intrinsically safe? These are all the things that we're going to be doing under a detailed inspection. The important thing to note about a detailed inspection as well is it is a requirement under the -17 standard that every piece of equipment that before it gets put into service must undergo a detailed inspection. So that can be during that construction phase, that once it's been installed, we follow up and we do have somebody else come in and do a detailed inspection on it, and then make sure that this is okay to be energized. So it is important to do that detailed inspection before the equipment gets put into service. Now, before it is, again, it could be given that initial detailed inspection by a competent person. And again, we'll take into account other relevant standards that might be applicable based upon a UK standard, an NEC standard, a different IEC standard, so forth and so on. But those inspection types, the initial one, that's to make sure that we check that selected type of equipment and protection are appropriate. Periodic, sample, and continuous are basically types in which we will undertake. The important thing from an EX perspective is that every piece of EX equipment must be inspected no longer than 3 years based upon the -17 standard. Now, how we do it can be either during these periodic, sample, or continuous inspections. So continuous inspection, that could be a situation where maybe we've got a motor that is due for an inspection, but yet we have to go out and actually do, say, something. We might need to check the insulation resistance on a motor during our normal maintenance operation. Well, during our normal maintenance operation, we can also do some of these other inspection activities. So we don't necessarily have to dedicate a particular person or time. It can be done by the normal maintenance procedures that are taking place. So in the -17, we have different inspection charts that we use. These are guides, and these provide details as to what should be inspected for each type of protection method and for each grade of inspection. So when you look up the -17, in the very back of them, they'll have these various inspection charts. These charts are critical, and these are important for, again, everybody to understand. Again, if I'm building a piece of EX equipment or building a bunch of EX equipment, incorporating them into, say, a skid package, it could be a hydraulic power unit, or it could be a water desalinization skid, or it could be, whatever it is. We might be combining a bunch of EX equipment together. We want to make sure that we're going through this detailed inspection and we're using these inspection check sheets, okay? You'll notice that it only really, these inspection check sheets are for D, E, and N, I, and P. There are other, obviously, EX protection concepts outside of those 5. However, most of those are usually at the component level. So for example, if I have, say, for example, EXM, which is encapsulation, that's generally a component part that you might find inside of another piece of EX equipment, such as a light fitting. So the light fitting might be EXD or EXE, but yet some of the components might be encapsulated. They might have other protection methods. So we basically will follow one of those other charts to make sure that those components are acceptable. So this is one example of the check sheets. So what you'll see over here it's basically broken down in, if you will, into different sections. There's A that will apply to all equipment, and then B gets into specific requirements and so forth and so on. On the right-hand side, you'll see EXD, EXE, EXN, and you'll see things, grades of inspections for D, C, and V. So for example, using that A1, equipment is appropriate to the EPL zone requirements of the location. We could find that information under a detailed inspection, or we should be looking for that under a detailed inspection. We should also look for that under a close inspection. And we can also find that as a visual inspection. So these check sheets, if you will, are guides for inspectors to use so we understand what we need to look for. And again, it's important, I think, for everybody to understand what these check sheets are, especially if you're having to deal with inspectors, because you want to check your own work. You want to check your equipment that's already installed. And before an inspector comes out, if you know what that inspector is going to be looking for, then you can address some of those issues before people like me even show up at your facility. And it always makes things go much, much quicker, faster, and generally less expensive, right? We want to catch these things before they happen. As I mentioned, within those schedules, and by the way, there's more lines to these. These aren't just the only lines that we look for, but I've just consolidated the check sheets into basically these little paragraphs here. So then we go into section B, the installation. So now we're looking at cable. Is there damage to cable? Are we filling the ceiling of any stopping boxes, cable glands, all that good stuff? And then finally, we get into our environment under C. And this is where we're looking to see if there's any effects based upon the environmental conditions. So conducting an inspection, it requires careful consideration of many things. The knowledge, skill, and competence of the inspector. Within the -17 standard, it does give some references to state what an inspector should have knowledge of. And so it is important to understand if, for example, you wanted to be an inspector, what is it that the qualifications are requirements based upon the IEC standard? Again, what is our scope of inspection? Are we inspecting everything? Are we inspecting just a handful of items? Again, type and grade, the documentation, availability of facility personnel to assist. So if I'm going to go into a facility to do something, then generally as an outside agency, I need to have somebody there with me to basically walk around because I don't want to be shutting off things. I don't want to be de-energizing things. Generally, I really don't even want to open things up. It really should be the client should be opening those things up, because if I open it up and I break it, well, guess what? That's my responsibility, right? Do I have access to it? The types of equipment to be inspected, and again, the environmental conditions. So safety is really the utmost priority. And by the way, these two pictures, I wanted to show the extremes. That was in southern Louisiana doing an inspection in summertime when it was about 100 and 102. And this was on a vessel that was up off the coast of Anchorage, Alaska, which was about, well, it was below freezing. So anyway, here's a couple things that you want to keep in mind. We don't want to take equipment into that hazardous area that's not suitable for that hazardous area, right? Cameras, key fobs, computers, so forth and so on, unless they're suitable for that environment. And again, opening energized equipment in a hazardous location without a gas-free permit is a big no-no. We don't want to operate those controls without the facility personnel. And again, not recording anything you believe may be incorrect or unsafe. It is always better to write something down that you think might be an issue, but then you can always go back and look at the documentation closer and find out, hey, is this truly unsafe, or is this something that is done correctly? But if you doubt something, go ahead and write it down. It's always better to be safe than sorry.
Oh, great, Bob. You look.
We have our
first pictures, you know. So we have a poll question for you guys. Make sure you'll be listening. It's an easy one. Which one of these is not a grade of inspection between visual, initial, close, or detail? One of them is not, you know, a grade of inspection. It should be easy to answer because you just mentioned it several times. Grade of inspections. And beside one is not related to grade, but it's more related to time. So, you know, it's yeah. But we give you a few moments for you guys to answer, then we'll show you the result. They're anonymous. We don't know who answered what, so don't be worried. And we're just looking at the percentage, not overall percentage. We have, most of you have answered. In fact, we have 90% answers. So let's terminate and show you the result. Most of you have answered correctly, if I got it right? It's, I've been listening, you know, I wanted to answer myself. Its initial was the right or the wrong answer. So the right, Bob?
You are correct. Yeah, initial inspection is a type of inspection. Visual, close, and detailed are grades of inspection. So if we go back to our inspection charts, here's our grades of inspection: detail, close, and visual. So you are correct. So
great. Well, some of you have answered close or detail, so you think about it next time.
Yeah, there you go.
Here we go.
Okay, so
more poll throughout the webinar, so keep that in mind.
yeah, pay attention, right?
Pay attention.
So Obviously, I mean, I know you can't necessarily answer this, but this is something that obviously, if you walked across and you saw, you could probably identify as a visual inspection, right? And the issue is obviously we have missing bolts. And unfortunately, this is pretty common, maybe not to this extreme, but it is critical that we have all these bolts spanner tight, or at least tight as what the manufacturer recommends. Because if we don't have the bolts tightened up,
We don't have a EX enclosure
we
anymore.
have basically no protection whatsoever. So yeah, this would be something that would be very critical that we'd want to jump on right away. Now, this is something that's pretty common that we see. And what you're seeing there is actually Teflon tape that's used between the gland going into the flameproof box and the gland itself. Teflon tape is not allowed, right? So if any of you would see Teflon tape on any of your glands that are going into junction boxes, that should immediately be a red flag for you. The reasoning behind that is Teflon tape, while it does provide a higher level of water ingress protection, that's actually a flame path. So if we have an explosion on the inside of that little transmitter housing, the metal to metal surface acts as a flame path. And now we've impeded that by the use of this Teflon tape. So it could do one of two things. It could actually potentially rupture the enclosure because it's blocking it from escaping, but it also won't cool off that hot flaming gas to escape to the outside. This is one reason, by the way, when you see that little black boot over the gland, a lot of companies will insist on not using shrouds because shrouds kind of hide, if you will, these types of things, these defects in the installation. So I always tell people, unless somebody really insists upon using a cable shroud, don't use a cable shroud, because all the reputable glands out there all have very high levels of corrosion protection, as well as high levels of ingress protection levels. So shrouds are, quite frankly, a very unwise decision, in my opinion, to use. And of course, we have to inspect these items at least once every 3 years. So to do a gland inspection, we would have to remove that shroud, right? And so we now have to put new shrouds on or do something like that, or try to slide it back into position. Now, this is another fault that we commonly see, and it's pretty obvious what we have here. We have what is called a traveling plug. And this is something that we should hopefully find under a visual inspection, right? So that traveling plug is this little red plug that you see plugged into that transmitter. Now, a traveling plug is meant, if you will, to help protect the threads, make sure that moisture doesn't get on the inside of this enclosure during transportation. But once it gets installed, we're supposed to remove that little traveling plug and replace it with a certified, in this case, EXD plug. So this is not uncommon. Unfortunately, we see this fairly often. And this is obviously not a good situation. We want to replace that immediately and get a certified plug in there. Now, this is kind of an interesting one. We have what is a little flame-proof transmitter here, right? And yet we see plastic glands that are going into it. Now, if we think about flame-proof, we typically have to use a metallic gland, and not necessarily a barrier gland, but we have to use a metallic gland that's rated EXD in order to provide EXD protection. However, in this case, this might be used or being protected by the use of intrinsic safety. And intrinsic safety would not negate the need for use of barrier glands or EXD glands. Now, what would be a dead giveaway of telling me that this was intrinsically safe is maybe they used blue plastic glands, or the cabling itself would have some visual indication that either by being blue or something, a tag on there saying this is an intrinsically safe circuit. But I don't have either one of those to give me that visual indication. So therefore, I would say, hey, this is a big problem. They've installed it as a D product, but they haven't used the proper glands. So here's something that is important to understand that you need to know, right? Because when I just mentioned about this product right here, this could be installed as a D product and it would have a certificate around EXD. but it could also be an intrinsically safe product depending on how it's installed. So if you look at a label, and this isn't that same product, but you'll notice on here, there's a bunch of different EX markings on it. And I'll see if I can actually annotate this here for you. So right over here, you see that there's a marking for EXD. That's telling us it's flame proof. Here's a copy of the certificate. But then right here, we see that, guess what? It's also could be intrinsically safe. And here's a copy of the certificate. Oh, and by the way, here's another protection concept, EXN, and here's a copy of the certificate. So it's important to understand when I mentioned that we should have copies of these certificates available ahead of time. We need to know how they're actually installing this product. Are they doing it as an EXD product? Are they doing it as intrinsic safe? Or are they doing it as EXN for non-arcing? If we don't know that ahead of time, then we're just going to be guessing, right? We don't want to do that. So we want to make sure that we do that. So let me see if I can undo or clear my annotations, and then we shall move on. Oh, I don't want to do that. I want to basically turn to my mouse, and here we go. So when we're also looking at cable glands, this would be one in which we would find under a detailed inspection, right? Because I mentioned to you earlier, opening up of cable glands at that point, if this is going into a flame-proof box, for example, we want to make sure that that box is de-energized, right? We don't want to do anything to potentially create an explosive atmosphere. But in this case, what we have is that the barrier gland, if you will, was not properly sealed. They're missing some of the compound around the individual conductors. So this is actually a requirement that we're supposed to do on barrier glands, to actually look and take a look and see if they've been properly poured. Now here's another example of, for example, some GMI products, which are the best products on the face of the earth, right? But if we don't install it properly, then we have issues. In this case, what we're finding is that we have things like, let's see if I can get my little annotation again, my draw. Let's see. Well, I don't know if you can see my mouse, but you can see basically we have some conductors here in which we have strands that are not terminated in bootlace ferrules. We have, it looks like we have some shields here that are just floating. This is basically a very, very bad installation, right? We shouldn't see any copper showing. Those should be right in the throat of a terminal. And that holds true for intrinsic safety as well as increased safety. So this is a very, very poor example of an installation. And again, we would find this only under a detailed inspection. The fault here is we really can't read this nameplate very well, right? We're going to be struggling with this information. So what we want to try to do in this scenario, we would typically find this under a visual or close inspection. So that's why we ask when we're doing inspections, especially on existing equipment that's been out in the field for a long period of time, we want to have documents, right? The documentation. So at least there might be some things that we can read off this to say, okay, yes, this is exactly the same product that was originally installed. Or in some cases, if the nameplate is completely missing, well, then let's get a GA drawing. Let's compare what's actually there versus our general arrangement drawing to make sure that we're really truly inspecting the right piece of equipment. If there's a piece of equipment that's installed that's not in our register, or it's not accounted for, or it's been replaced, or something like that, those would all be faults, right? So we can't just necessarily, it's in some cases, it's okay to replace an item with another item that's suitable, but we should have taken note of that and record that in our register, and we should have updated information on the new product that's replacing the old product. So this is a product, a light fitting, in which obviously moisture was getting on the inside of this, and we may or may not have been able to identify this under a visual or close inspection. But under a detailed inspection, we can see, yes, we're having some problems here. So in this case, we've got, electrical components potentially sitting in water. which is not necessarily a good scenario, right? So this would be something that we would definitely want to take note of and make sure that the client is aware of this.
Okay, is another.
So another poll question.
Yeah, you mentioned this. What standard do we follow for EX inspection? You mentioned there's a main standard. You mentioned it earlier. You also said that we have to follow other guidelines. Maybe the customer, the end user, has his own guidelines, but there is a standard among these IC standard. It's either -14, -1, -10, -1, or -17. One number sounds familiar. Let's see if you guys can answer. We have had 11. Wow, it's super fast. You guys are following. Now they're taking notice. 100% correct. You answered -17. I believe it is -17, and all of you answered in. I mean, I don't know the time.
Yes.
Check this time later, but it was very
If
fast.
if you don't remember anything from this webinar, you'll remember -17.
17, yes.
Standard,
Great,
right?
thank you. Guys, you are paying attention. Okay, let's.
Well done. Well done.
Well done.
So here's another fault that this comes up, with flame-proof flanged enclosures, right? This is a little bit of a difficult one to determine whether or not this is dangerous or not dangerous. Obviously, we would find this under a detailed inspection, but whether or not that's enough of a gouge and that it transmits all the way across the flange, you might argue in the standpoint that this may be not a critical safety factor, right? So as an inspector, sometimes you're faced with these types of issues in the standpoint, hey, is this a safety critical issue or not? And sometimes it's a little more difficult to make that determination. What I would do in this scenario is I would write it down and say, hey, Mr. Customer, this is obviously something that was done someplace, somehow, somewhere, either at the manufacturing side or maybe after the fact. And you, Mr. Customer, should make that determination as to whether or not you feel that this is still suitable. But you could certainly argue, and some inspectors could take the approach to say, you know what, that's obviously damage to the flange. That's an issue, remove it, start over. So there's sometimes a little bit gray areas that are not necessarily well defined, and you have to make a judgment call. Always, 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 though, write it down and make sure that people are aware of this. And certainly you're valid in providing your opinion, your expert opinion, but ultimately it's going to be up to the end user or the regulator or whomever it is to make that determination of whether or not this is acceptable. Obviously, in this scenario, this is not acceptable, right? We have a lot of water that's accumulated on the inside of these EXD boxes. This would definitely be an issue. I can't imagine that these enclosures are actually, or this motor, if you will, is actually operational. So obviously we'd have a big issue here. Obviously, we need to get that water out and figure out what caused this in the first place. When we do look at cable glands, right, again, a detailed inspection, or we might have found this maybe as a close inspection, where we loosened up a gland and all of a sudden the back end came off and we see that the armor is not clamped. So this would certainly require you to inform the client that, hey, these need to be reinstalled. It's also important to understand that when we go in and do inspections, if you notice there's a bunch of glands sitting right behind it, right, that are covered with shrouds. If I saw this scenario, and I did, I would immediately say, look, we've got 3 glands that I've opened up. All 3 of them are wrong. Then I can probably safely assume that, hey, we need to open up each one of these glands because I don't feel comfortable with this. I feel that we have an issue with all of these glands. So if on the other hand, I open up a sample amount, maybe 5 to 10% of the glands, and all of them are properly installed, then I can make an assumption that say, hey, look, I've inspected maybe 5% of the glands, everything was fine, we can move on. We don't need to necessarily inspect 100% of every product. Now, what we have here is actually a couple things, but and you really can't tell from this picture, but obviously this is on the inside of a flame-proof box in which somebody has taken some putty compound to, in effect, use that extra putty to seal up around cables that are going outside cable glands. But there's another issue here which you don't know, is that that cable in the forefront is actually light blue. That's intrinsically safe cables. It's okay to run intrinsically safe into an enclosure that doesn't contain or has a mixture of both intrinsically safe and non-intrinsically safe. But we actually require a segregation or separation of at least 50 mils between those cables, unless those cables happen to be shielded or armored. Now, what happened actually in this panel in another picture is that they actually came very, very close together, and they defeated that 50 mil separation. So that is an issue as well. This is an issue here that may not be necessarily completely obvious to some of you, but if you look very closely, and I'm going to try, if my will this time, to maybe do my little annotation. Where can I do it? Here we go. I think I got it. If you notice right there, or right there, specifically these little, the U at the end of it. Oh, this is interesting. It disappears after a while. So these little U's, that is basically telling us that this is a component. And in the Dash 14 standard, which is our installation design standard, it says that we cannot use a U certified component unless it's part of an overall system. So what this meant was that this customer ended up buying some empty enclosures without any terminal blocks. They populated it with terminal blocks and did their own thing. When I came in and saw this, I realized, hey, you guys got a non-assembly certified product, which would have either an X at the end or no letter. And in turn, you populated it yourself. This is not acceptable. So in this case, what we had to do is that we actually had to take pictures of this, send the boxes back to the manufacturer, who in turn issued a new certificate, a new label, put new labels on it. And of course, that costs time and money. So we don't want to do that if we don't need to. So here we have kind of a potential issue here. We have some intrinsic safety that's mixed up with non-intrinsic safety. And again, we're violating our 50 mil separation. We also have some connection points that are not terminated. So there's quite a few issues here. This is fairly obvious, I would think. This is something you would see. That's an explosion-proof or flame-proof box in which there's a seal fitting or stopper box in which basically due to corrosion, it is disappeared, right? So at that point, even though we have all those bolts nice and tight, we're now missing an explosion-proof seal or a seal off. And so that is definitely a dangerous situation. Here's a scenario, again, where we're opening up now an enclosure. We're looking at things like the gaskets, if they're built in. This is fairly common, right? The gaskets sometimes the glue might wear out a little bit, and then all of a sudden we close it up, and that gasket is now sitting in the flame path. So we've done a couple things here. We violated the ingress protection requirements to maintain a high IP rating, but we've also basically defeated the flame path here, because now we've increased that gap. And if we had an explosion on the inside of this enclosure, it probably would not be able to properly withstand it and cool it down. So in this scenario, we'd want to obviously replace that gasket. Now, what's the issue here, right? This was one that I did here not too terribly long ago. A flame-proof box, been in service for quite some time. And actually, it's got a combination of intrinsic safety and non-intrinsic safety. There was a fairly good amount of separation, but here was the thing. I didn't have a drawing of this particular unit when I did the inspection. And so if you notice on the right-hand side, there's a bunch of intrinsically safe barriers. Well, as it turns out, when I got the drawing later on, I actually found that the barriers that were installed in the inside of this panel were a different brand and different make of intrinsically safe barriers than what was actually originally installed. So that is a big issue, right? That requires a reevaluation of this panel, because now we're doing something that was outside of what was original design on this. So even though we look at this and we say, hey, it looks pretty good, as far as we know, there may be some separation issues on IS and non-IS, but everything looks pretty tidy. However, in this particular instance, the issue was we didn't know until we got the drawings that there was actually components that were not originally part of the certification of it. So it's critical to have these drawings before we do our inspections as well. So there also should be what is called an EX register. And it basically can take many different formats, but this is our document, if you will, that we either as an inspector are going to want to see, or maybe we'll build it. And I've done that, where we take this information, we'll load it into an Excel spreadsheet. And this should be a living, breathing document that goes with that equipment for the life of the equipment. Because we want to make sure that we have all this documented. So we're going to have tag numbers, we're going to have a description, part numbers, we're going to have certification numbers, and we're going to have all this good stuff. And notice on the right-hand side, it says X condition. So the X condition for that first item, that level switch, the X condition said the flame path not to be repaired unless by factory, right? Okay, well, if there's no damage to the flame path, then we don't have to worry about it, right? There's the third one down. It says paint, if applied, must meet the anti-static requirements to meet the requirements of Dash 14. So if somebody came in and painted that particular unit after the fact, I'd want to know, hey, did your paint meet these requirements? And we would have to go look at the requirements in the Dash 14 to confirm this, right? So it's important to understand these X conditions as well for the products. So when we're doing a full inspection, we understand that this product has been installed in accordance to the requirements of the manufacturer. Now, there are some tools available to help facilitate these inspections. There's everything from EX tablets, RFID tags, and readers. And on the right-hand side, you actually have like little EX little buttons that you can actually attach to EX equipment. That in effect, what you can do is go up to it with an RFID reader, plug that in or tag it, and then it'll bring up all the information in your tablet with all your software. So you can do all of these inspections using some readily available tools. Most of the time, we still do them by pen and paper, right? But there's a lot of tools available out there to be able to minimize the actual hard work that you need to do. And many oil and gas clients have standardized on various software packages, and this is what a lot of people will utilize today.
Okay, so it's our, I think, last poll for today.
I think so.
Just this very early on, I have to say that was easy for me, because I had to see the poll, so I've been listening to you. Which one of these protection concepts does not have an inspection schedule chart? We have EXD, EXC, EXM, or EXP. One of them does not have its own specific inspection schedule chart, and you said, you have to follow the schedule chart of the main. Well, I get too much. I give you too much. Some of them you mentioned that might be components level certification, so you have to follow that of the enclosure or the installation, the main certification. So, and we are 10 minutes in from the end of our webinar, so let me give you guys a couple more seconds, and then we'll show you your reply. Okay, let's call it that. We have over 80% reply, and most of you got it right. There was encapsulation.
Yeah. Right. Encapsulation, I mentioned that early on, but yeah, encapsulation is usually at a component level. Mm-hmm. So we don't have an inspection chart for encapsulation, but we do have them for flame-proof, increased safety, pressurized, as well as intrinsic safety as well.
Great.
So just some key points to remember. Again, in doubt, if you think it's a fault, write it down. Become competent. Go through an EX competency course to understand more. We offer what is called the IEC EX Certificate of Personnel Competency Program. It's a great place to start. Here's one thing. I've been doing this for many years, but I always find things that I've never come across before. Most of the time you've seen it, you've dealt with it, but don't get cocky, right? Don't become arrogant. Realize that you don't know everything. So always refer back to the standards. Here's another thing. The more that you know about the standards, the more that you understand what an inspector is looking at. There are times where I've had people that, they've said, well, wait a minute, we don't think this is an issue and this is the reason why. And I'm always willing to listen because sometimes people will say, yep, okay, I get what you're saying. Or on the other hand, I'll say, no, it says this right here in the standard. So the important thing is we don't want to be an adversarial relationship, right? We want to work together to make this right. But if you're being arrogant or, you know everything, then, that doesn't help the situation, right? And again, never let outside influences affect your judgment. These are safety critical functions. Lives do depend on your work. And here's the other thing, regardless if you're officially inspecting equipment systems or not, do it, right? If you see something that doesn't look safe, report it to your supervisor. And here's the last thing, stay on top of your game. Realize that the standards change. Generally, these standards change every 5 to 6 years. And there's going to be some new changes, I know, in the new installation design standard that are coming out next year, that there's going to be some big changes. The inspection standard hasn't changed for about 6-7 years now, and I know there's some move afoot to make some changes on that. So stay on top of it, right? And again, safety begins with you. So now we're not quite.
All right, Bob, that was really great. Let me share.
Stop share mine.
Yeah, I managed to catch you off. Let's see.
Okay.
So we through the registration process, you guys posed some questions, so we are going to answer them. As I mentioned earlier, we still have a few minutes. You can pose any question live through the question and answer box. So let's go with the first one here.
Okay.
Let me see if I can manage. So what is the role of inspector quality control during engineering and design construction phase of the process? Well, that's a tough one, Bob.
Yeah, but it's a good question, right? We always think of inspectors being involved at the later stages, right? But if on the here's where it comes into play, is that at the very early stages when we're actually designing our around our equipment, right? When we're doing our selection of components, it's important to understand things like the conditions for safe use. So any product, and this is true under ATEX and IEC-EX, if it has an X at the end of its certificate number, we want to pull that certificate. We want to look at that during that design phase, because there is something in there that's telling us, hey, if we're going to use this product, it has to be installed or used in a particular fashion. If we don't do that at the very early stages, and then it's all gets built and everything gets done, then guess what? We find that there's major issues. I'll give you 2 examples. A major project that was executed here in Houston a couple of years ago, in which they selected a particular cable gland. This cable gland had an X condition, and they didn't look at it at the very early stages. They bought 11,000 of these cable glands, sent them to a facility in North Africa for a new expansion of a refinery. The inspectors came out and found out that the X condition required that cable gland had to have a clamping mechanism within 300 millimeters of the back end of that gland. Now, guess what? Of the 11,000 cable glands that were installed, only about 5,000 of them actually had that. The other 6,000 cable glands didn't meet that requirement. So that forced the contractor to go back in and basically build brackets, do all different kinds of things to be able to secure through the use of cable ties or strapping or whatever, to be able to secure the other 6,000 cable glands. If you don't think that costs a lot of money and time, oh my goodness, right? The other thing, there was one I did here not too long ago in which a plug and socket assembly was certified with an X condition. The X condition basically stated that this equipment could be only installed in an environment in which it was not subjected to potential impact. Well, the way that this plug and socket was actually installed on this skid, it was sitting on the outside of this skid, which could be exposed to anybody walking by or anything like that. And I pulled up the X condition. I showed the designer. I said, hey, you're going to have to move that. And he was like, well, I don't have any space. I said, well, put a cage around it or do something, because where it's installed right now violates this certificate. So as it turns out, they were able to move that into a location where it wouldn't be subjected to impact or something like that. So it's important to understand these things before we do our design, because again, if we just go and start picking out products and we do our design, then guys like me come in and we're jerks and we tell you all these terrible things. If you know that stuff ahead of time, you could be much more prepared, and you don't have those issues at the end of the day.
Great answer, Bob. So here's the next one. What is the relationship between IP code and EX protection? Is there a relationship?
Yeah, there is. There is minimum requirements for ingress protection. So we saw that box earlier, which was filled up with water. Generally speaking, EX equipment requires a minimum of IP54, ingress protection of IP54. However, just because the minimum is the requirement doesn't necessarily mean that that's what the project. I've seen many projects in which they require a higher level of IP ratings. You can see that little control station on the right-hand side as they're opening them up. Water is obviously leaking out. Now that enclosure, quite frankly, is a IP66/67 enclosure, but the way it was actually installed, and you can't see it from this video, but it looks most likely they probably had a gland on the top that wasn't properly seated, and it allowed water to accumulate on the inside of this box, and therefore now all of a sudden you see all the water leaking out.
Okay, let's move forward because we are closing to an hour. Inspection on the XD barrier gland. Many of them is not able to be splitted from inspection due to their potted with too much casting compound. And many of them are filled up with too large cables. So, not properly installed.
Yeah, it has been a big issue. There are some gland manufacturers now that are taking barrier glands and they're making either clear pots to be able to inspect it. And what we don't want to see is gaps, right? We want to be on the right-hand side. You can see that we've got the compound all the way around those individual core conductors. So that's important.
Like this earlier we saw.
Yeah, the one on the left-hand side is correct, and here's where we could have damage to cables from non-barrier glands.
Are there courses available to become an inspector?
Yeah, so there's different courses around the world are available. The two major ones are, one is called COMPEX, and the other one is called the IEC-EX Certificate of Personnel Competency. So here's the one thing. Both of these courses, they take usually about anywhere from 2 to 5 days. And we have people that come out of these programs and they say, okay, now I've got my piece of paper. Just because you have a piece of paper doesn't make you necessarily competent. It just is basically is giving you the benchmark, if you will, to say, okay, look, you can start doing this. But it ultimately comes from your experience and working with other competent people to develop your level of competency. And you're always learning, right?
Right. So you need to train some guys, younger guys, So how often does EX equipment need to be inspected? I remember you mentioning, honestly, guys, the first time I see this, so I don't have time to go through this presentation before we actually do the webinar. But I remember you mentioned 3 years, right?
Yes, every piece of EX equipment shall not exceed 3 years, right? But there are some specific examples where it has to be more often. Movable equipment, handheld equipment before each use. All equipment shall be submitted to a close inspection every 12 months. For example, battery enclosures shall be given a detailed inspection every 6 months. So there are some deviations, but basically every 3 years is what the IEC standard says, that we have to do at least a visual, close, or detailed inspection.
Okay, we come into an hour. I saw somebody's already trying to move out, but let's give it a second, few more questions. Do you
Yeah.
take polls that you find in the same fashion, or is there some sort of way to determine which are more, critical than other? I guess so.
Yes.
Let's see a chart.
Yeah, so this isn't in the -17 standard, but just because we go through the -17 standard, it tells us yes or no. It's basically, is that a fault? Yes, it is. So now that we've determined these faults, now we have to determine how critical these things are. And companies will take something like this. This isn't, again, part of the standard, but some companies will use this and they'll say, hey, if it's a code 1 or priority 1, this means that this requires urgent attention. That could be something like bolts missing on a flame-proof box, and so forth and so on. For example, the code administrative 4 doesn't comply with the standards. Well, that means that maybe it's missing a label. Does that mean that we have to shut down this facility because it's missing a label? No. So we weight these faults, if you will, based upon a prescribed description. And this is usually come up by customers, clients, best practices, but this is not within the -17 standard. So this is above and beyond that.
Okay. So we have a lot of questions all the time that we are interested in webinar on something other than the one we are promoting. So we do have live webinar scheduled. You can go online and see all of that and see what is up next. And we have our last poll, which is, for Bob, honestly, not for myself.
It's for you. If it's good,
How was this webinar? Was it what you expected? Was it good? Not good? You can answer this, and then we will close unless we have a live question, which I don't see in my screen. So great. And I see we have all of you have answered. Terminus and Joe. It says here and show the results. So we have 90% plus with an excellent and a good. So thank you, Bob. As usually you'll get this type of answers, let me interrupt the condivisione. Here we go. So I see most of you are still there. Thank you, guys. Thank you, Bob. Excellent as always. Your knowledge is, how do we say? It's a great knowledge.
Thank you.
Guys.
And please don't hesitate to reach out to us if you have some specific questions or if we can be of assistance. I know we kind of blasted through this information in a very, very quick time frame, but if you need some assistance or would like some assistance, don't hesitate to reach out to either myself or Paolo. We'd be happy to help.
Yeah, just send us an email. Thanks a lot, guys. Thank you, Bob. Good evening. Ciao. Bye-bye. Bye-bye.
Ciao. Bye-bye.
Bye-bye.